quadratic functions in both vertex and intercept form. So with quadratic functions, we have our parent function, y equals x squared. So let's start by creating a table and graphing this. So we have our input values x and our output values of y. So let's start by inputting 0. So if you input 0 into this equation, our output would also be 0. If we were to input 1, 1 squared is 1. Input 2, 2 squared is 4. Input 3, 3 squared is 9. And you can also do the same with negatives. Negative 1 squared is 1. Negative 2 squared is 4. And negative 3 squared is 9. So we can go ahead and graph these points. 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, and 3, 9. And from lesson 4.1, we have all seen a graph of this form already. I'll try that again. And that right there is a parabola, or the graph of a quadratic. So from this graph, we can tell that our vertex of our parent function is 0, 0. This is also the lowest or highest point on the parabola. In this case, the lowest point. Our axis of symmetry would be that line right down the middle of our parabola where it reflects, and that would be x equals 0. As it said, this divides the parabola into mirror images. Your axis of symmetry must pass through the vertex, and we write the equation as a line. So the y-coordinate is either the max or minimum value of your parabola. As we talked about this in lesson 4.1. In this case, we have a minimum value, and when we input 0, our output is also 0. So our minimum value is 0. I like that they pointed this out. We must use at least 5 points on the graph, especially when it comes to parabolas, in order for it to be accurate. Okay, so our first key concept here is we are taking a look at our vertex form. So vertex form, very similar to standard form, although our A value is out in front now. We have our H value and our K value. Okay, these values, you guys are used to seeing a concept like this, a parent function, from our absolute value equations. Because how we graph those, you will see very similar transformations to this. Remember, our H value will move our graph horizontally, and our K value will move our graph vertically. Okay? So, these characteristics below, we have the vertex is H comma K, where your K value is your vertical transformation and your H value is your horizontal. The axis of symmetry changes to whatever your H value is, and the graph will open up or down depending on your A value. This is the same as our normal quadratic equations. Okay, transformation reminder. If the absolute value of A is greater than 1, your graph will be vertically stretched. And if it is less than 1, the absolute value, so you have a fraction or something like that, your graph will be vertically compressed. Okay, just a reminder, we have already covered this before. So let's look at vertex form in action. Okay, vertex form, especially in example number 1 here, looks very similar to our standard form minus having our x value. So we actually need to really write this one in vertex form. So it's more similar to what we have over here. So we have y equals, our A value stays the same, negative 1/2. When you have x squared like this, that's the same as saying x minus 0 squared. right? Anything minus 0 is itself, plus our 3 on our outside. So from here, you can tell our vertex is our h value, which in this case is 0, and our k value, which is 3. So we have a vertex of 0 and 3. Okay, that's a good starting point for us to start at. So let's fill out our table. X, Y, we need to have at least 5 points, but we might as well start at our vertex, which is 0, 3. Okay, let's do 2 points above, which we'll just take -2 and -4, and 2 points below. So if we were to substitute -2 into our equation, we'd have -2 squared, which is 4, times -1/2, which is -2, plus 3, which gives us 1. With -4, we would have 16 times -1/2, which is -8, plus 3, which gives us -5. And we know this will reflect, so we have the same values on the positive side. Okay, let's go ahead and graph these. We have 0, 3, -2, 1, 2, 1, and 4, -5. Just like that. We can go ahead and draw in our parabola. And then one more thing that I'd like to do is we have to compare it to the parent graph. So we might as well list a couple of transformations. Okay, from our parent graph, which is our parabola up above, you can tell that our new parabola is reflected over the x-axis, or it opens down. Or opens down. Okay, it is vertically compressed since we have our a value is less than 1. So you can just say vertically compressed. And then finally, we have a vertical or a horizontal shift of 0, right? Our h value is 0. Yet we still have a vertical shift of 3. So we can just say shifted up 3, right? Those are all of the transformations that we did to go from our parent graph to the graph we have below. Okay? So with our vertex form, we'll save number 2 for class. But let's take a quick look at our intercept form. So intercept form looks a little different. Okay? Intercept form is kind of like a factored form in a way, where our P and Q values are our x-intercepts. Okay? Those are our zeros. Okay? The axis of symmetry is halfway between our two intercepts, right? So we could take P plus Q and divide it by 2. This is very important when it comes to this form. And same as all of our forms thus far, if a is greater than 0, it opens up, and if a is less than 0, it would open down. Okay, so let's just take a look at number 3 for now. Okay, in this form, our x-intercepts are the easiest thing to find. Our x-intercepts are negative p, I didn't remember what order, negative q and negative p. So our p value is 3. So our intercept would be -3, 0, and you would also have the opposite of our q value, 1, 0. So that is a great place for us to start. Okay, those are two free values. Another thing that we know about this form is our axis of symmetry, which is P plus Q divided by 2. So our axis of symmetry, or our AOS, is P plus Q, so -3 plus 1 divided by 2, which would just be -2 divided by 2, or x equals -1. Okay, so we know our axis of symmetry helps us find our vertex. So if we were to fill out this table, let's take our -1 value and substitute it into our equation. -1 for x would give us -2 times 2 times 2. So that would give us -8. And that right there is our vertex. So let's draw a couple points above and below. So we have -2, -3, -4, and then we have 0, 1, and 2. So we already know if we plug in a -3, we are going to get a 0 in return. Same goes with 1. So let's just fill in the blanks. 0. 0 times 0. Well, 0, sorry. 0 plus 3 is 3. 0 plus -1, or 0 minus 1, is -1. So 2 times 3 times -1 gives us -6. And we know this reflects. Same goes with 2. That would be 5 plus times 1 times 2, which gives us 10. We know this reflects as well. So let's go ahead and plot our points. Let's start at our vertex. We have -1, -8. We have 0, -6. We have -3, 0, and 1, 0. Oops, I drew this one too over. Let's fix that. Okay, and we also have -4, 10, or 2, 10. So we can go ahead and try to graph this best we can. Okay, and if we were asked to, we could graph our axis of symmetry, which is what we found right here. All right, so I do not have a timer on this video, yet I imagine that it's probably fairly long at this point. So we are going to call it there. We showed one example of vertex form and one example of intercept form. So coming to class, we will take a look at more of these examples, and hopefully, we can clear up a couple things if you have questions. Okay, so if I was you guys, I would for sure try 4 on your own. I would for sure try 2 on the other page. And then if you'd like, you could try these as well. We have a vertex form example and an intercept form example. Okay, thanks for watching. Thanks for sticking with me. And we will answer questions in class. Thanks for watching.